This is Spiral Galaxy NGC 3982. What a gorgeous, naturally occurring object in our universe. Well, I mean, it ends up being gorgeous after all this work. And that's true of pretty much every photo you've ever seen of space. They're all photoshopped to perfection.
And I'm sure you're wondering why they do it. But the methodology behind how they do it is just as, if not even more interesting than that.
Okay, so the most important thing to get out of the way here is that none of these photos are fake. According to the space agencies that took them, they're just interpretations of our reality. These interpretations, however, are edited as NASA, the ESA, the Canadian Space Agency, and most, if not all other space agencies, Photoshop the images they take of the universe around us. While the term photoshopping bears a lot of negative connotations, like models getting airbrushed to perfection or people faking experiences they never had,
this is not the case with space.
Everything you get from NASA is real. It's real information in the real universe. Yes, the pictures are enhanced or altered, or the colors are changed, but it's done for real scientific reasons, not just because we feel like it, and definitely not because we feel like making things up.
That's Dr. Paul Sutter, an astrophysicist at The Ohio State University and host of the podcast Ask a Spaceman. He helped me understand what those scientific reasons for altering photos of space actually are. First off, images of space are taken not for beauty, but to gain information and insight about the universe around us. Most of the photos taken of space come to us in grayscale, a monochromatic color range that's pretty bland and boring if you're talking to the average person. The reason for this is twofold. First, color cameras are just lower resolution than black and white cameras. To produce any image, cameras require sensors to capture light. For black and white cameras, this sensor is working with all the light that comes into the camera. But with the color camera, you need red, blue, and green receptors to get all the different colors to make up the world. Each receptor is only picking up 1/3 the light that it normally would, which when put together creates a less sharp image than you'd get if you were capturing all of the light you were capable of. So flatter, less colorful photos are ideal when it comes to getting the most information you can out of a photo. But of course, monochromatic photos aren't as visually appealing as color photos, both when it comes to aesthetics and when it comes to quickly grasping information. The human eye has a limit to how many shades of gray it can distinguish between. So scientists composite multiple filtered photos into one image to approximate the real colors you'd get with the color camera. And then, since they're already there in Photoshop, you figure you might as well zhuzh it up just a little bit.
We're visual creatures, and we like looking at pretty pictures. We like putting pretty pictures in our papers, and we like showing off pretty pictures to the public. We could share charts and graphs, which, while perhaps more scientifically useful, just isn't as interesting. So here's the cool picture that led to that chart and graph.
Colorizing photos is more than just trying to increase the appeal of an image.
Frequently, colorization is also used for categorization, just like how we categorize Excel spreadsheets, wires, and maps. Extracting all the information you can out of an image to learn more about the universe around us means gathering light at larger spectrums than what the human eye can see.
Because we can only see this little bit. With technology, we can see all these things, and those would be pretty much invisible to the naked eye or a regular camera. Check out this image of clouds where stars are forming. These clouds are somewhat opaque and would be very difficult to see with a regular camera, but thanks to infrared telescopes, we can parse them out and build a better map of our universe.
Next, scientists have to decide how they're going to color code it, and sometimes that can be a little bit challenging.
What color is 143 megahertz? There's no color for that. So we assign a color to those frequencies, just like the human eye assigns a color to particular wavelengths of light. So what we're doing when we're collecting data or collecting light that is outside the visible spectrum is we're assigning colors to it so we can actually look at these things.
Colorizing photos can also help teams of scientists understand more about the composition or elemental makeup of the universe. Different elements give off different wavelengths of light. So if one scientist recognizes a certain element as hydrogen or sulfur, for instance, it's helpful to single that out so that everyone else on the team can identify that just from looking at the color it's painted as.
If you look at a picture of a typical nebula, like the Orion Nebula or Cat's Eye Nebula, this isn't necessarily what you'd see with the naked eye, because the colors that have been added here are used to highlight where certain elements are. Like, oh, if there's a lot of oxygen over here, we want to paint that like a nice pretty blue. And if there's a bunch of iron over here, we want to see some red. We're assigning colors to those various elements so we can see where they are in relation to everybody else, so we can try to understand this nebula and how it was formed and how it will evolve.
All these methods for photoshopping are in the effort to get the most information possible out of space and interpret it with the least amount of effort.
So NASA and pretty much every other space agency out there photoshops their images. Not because nothing is real and the Earth is actually flat and everything you know is a lie, but for the purpose of doing a better job at being astronomers.
The colorization of photos, I would say, is 10% for the benefit of the public, 90% for the benefit of scientists. We are intentionally colorizing the images because we're trying to understand them. And sometimes natural color, or what you would see with your eye, just isn't going to give a lot of information. That's why we have these big giant telescopes in the first place, so we can do stuff that we can't do with our eyes. And so, yeah, we're going to process them, we're going to Photoshop them, but every single thing we do in astronomy is based on the data. We're not making anything up. We're not faking anything. We're not inserting anything. We're highlighting what's already there so that we can, do our job as scientists.
To keep up with more awesome content, subscribe to our channel and hit that notification bell so you can always be updated with new videos.